Welcome everyone to our first video on the ellipse. I've just titled it the ellipse sheet 1. I'm planning on doing 2 sheets in total here on the ellipse, and I'll be taking it from the real basics right up to, I suppose, the harder principles and practices that we need to know for junior cert or junior cycle graphics. Just to get started there, at home you're going to need to lay out the sheet just somewhat like I did here. I want 6 drawings, so I have 6 centers for 6 drawings on this A3 page. The dimensions, from the bottom of my page I went up 80mm and drew a line across. From the top of my page I came down 80mm and drew a line all the way across. From the left hand side of the page here, 75mm was the first center, and I just I took a vertical line through that. I skipped a little space. I don't want to link my 2 drawings together, so I skipped a little space here in the middle and I brought it on down, so they're both at 75. From there along is 135 from center to center, 135, and then just light vertical lines, and another 135 then from the second to the third drawing. Get that much set up and then pause the video and check back in once you're ready, and we will get started. To get started, I want to just start off with a very basic really. I'm going to just draw a major and a minor in this first position right here, and I'm going to go ahead and draw an ellipse. So the dimensions I'm going to use here is 40mm radius for the minor and 60 for the major. So I'll mark those 2. I'll grab the compass and I'll go ahead and draw. So there's my minor, radius 40, diameter 80. There's my major, radius 60, or diameter 120. While I'm at it, I'm going to just drop in the same 2 circles down here as well in this position. Okay. I'm going to also draw the same one here. And here. Now that means I have my 60mm drawn in 4 positions, 3 along the top and 1 down here. I'm going to get my 40mm here. I'm going to draw it down here as well. Okay. I'm going to just set it a little bit smaller than 40, and I don't know what size I just set it to. It's just, I know it's a little bit smaller than 40 there, and I'll just draw 2 of the same size circles. One here and one here. Now that is 6 ellipse questions ready to go on our page. Now I want to just take note of what the question is in each case. Okay, so number 1 up here is a major axis equals 120 and minor axis equals 80. Okay, and I want horizontal ellipse. Now, horizontal orientation, which just means that when we draw it, we want the curve to be facing somewhat like that. Okay, so that's the question that we're being asked there for question 1. Just add a little bit of background colour to that. That is the question there for number 1. So it's a major axis 120, minor axis 80, and it's a horizontal ellipse. And I'm going to work, that's going to be number 2 across here, but we won't go to that yet. That's going to be number 3 across here. Number 4 down here at the bottom is, again, major axis equals 120, minor axis equals 80, and it's going to be a vertical ellipse, which looks somewhat like that. So there's 2 of the questions. Okay, that's 4. This is going to be number 5 here, and this is going to be number 6 here, but we won't worry about the wording of those guys just yet. What we're going to do is we're going to solve number 1 and solve number 4 first of all, before we go ahead and work across our page. 1 and 4 are the same difficulty. These are the real basics. So if you're given the major and the minor, now I started off this page saying I marked 40 and 60, but usually when we're given the terminology for an ellipse, they always say the major axis. They don't say the major radius, but sometimes they will. Keep an eye out for it, okay? So axis being the full diameter, radius being half that. The first thing we'll do is we'll just recognize, given this type of ellipse here, a horizontal, we want it on the major horizontally. So we want it to touch the far left and far right point, and we want to compress it down until it's touching the minor here and here. So that's going to be the ellipse. We know in the shape that it's going to be, and that's just from the hint in the question. Now usually in questions you'll see in books or in exams, they don't tell you it's horizontal or vertical. You just look at the diagram or the finished shape and you'll see whether it's a horizontal or a vertical. So once you know what type you're looking for and you have your 2 major and minor drawn, then recognize and identify the first 4 points that are going to be on your curve. You're going to do that for this one as well in a while. Next thing we'll do is we'll break that circle up into 12 segments. So using our 30-60 there, we get it broken up into 12. What I wanted to recognize here before I move on is this. We took it from the major position and we went down to hit the minor. So it's compressed from the major position down to the minor, and here at the base then it's compressed from the major up to the minor. So I'm going to have to think about that rule as I go forward here, and I'm going to work on the top half first. I'll go from the major down. I'll go from the major down. This time I went down to hit the minor. I could do that here, but it would be wrong, and I can't possibly do it here because it won't hit the minor anywhere. So what we do is we link it to the minor. We link it from the minor across. So from the minor across, and that gives me a point on my curve. From the minor across, and I get a point on the curve. So I know now that my freehand curve is going to go from this point through, and to this point. I'll do this on the left hand top quarter now as well. So from the major down, from the major down, from the minor across, and from the minor across. So my freehand curve that I might just get started with right now is going to look something like this. Now I'm going to have to clean this up nicely, maybe rub off some of the doubles I just put in there after, but that's the top half of the curve. I'm going to clean it up a little bit thereafter. Working on this bottom half of the curve from the major up. So from the major point here, up, major, up, major, up, and up. From the minor out to hit, and this one should line up, out to hit. This one here, out, and this one here, out. Up there we get all of our points on the ellipse. That is all of the points that are necessary to draw this ellipse here. And we just freehand it all in. Now ideally you'd stand up, or maybe if you were kind of finished the drawing you might move your sheet around a little bit. I like to stand up to draw these curves in because it gives you a little bit more control and movement to try and get the curves as smooth as possible. I will pause the video in a while and I'll clean up that curve a little bit and just outline it nicely just once. But before I do, I'm going to go down here and I'll draw a vertically orientated ellipse. So first of all, identify the points. So it stands full size on the major, standing up here to here, and it gets compressed in to the minor here, and here. So there we are. That's our movement identified. It's what's happening. Well, it's going from the major here, and it's going in until it hits the minor, and the same. It's going from the major here, right in across the drawing until it hits the minor. We'll just keep that in mind as we go on ahead. We'll do the same thing again. We'll break it up into 12. Now, I'm going to work on the left half of it here first. What did I do? Back in my red position, well, I went from the major in across towards my axis. And that's what that looks like. There. Third position. And fourth. I'm going to come up. And there. And down. And there. And I go to these two, which happen to line up as well. Down. And up. And I start seeing where all of the points are going to be on this ellipse as it starts to form. So that's going to start to form nicely for me. I'll go ahead and do the same here. So I'm going in or across this time. And across and up and down. So down, up, from this point in the minor, down and up. And there's all the points again. So that is just the basic construction. When you are given your major and minor, you can start constructing an ellipse in a vertical orientation like I just did right now, or in a horizontal orientation like up there in question 1. You have to really train the hand, I suppose, and get used to drawing these freehand curves and just trying to keep them as neat as possible without any real imperfections in them if you can. But I suppose that all comes with practice. In a few seconds I'm going to pause the video. There's no need to watch me freehanding anymore. I will pause the video and I will try to clean up these curves just that little bit, and then we can replay the video. You can pause it as well at this time. Spend a little bit of time. Once you're getting your curves nice and close, then it's time to try and clean them up and go for one nice profile to finish and try and get it nice and smooth. And if you double over like I just did there, keep going on ahead. Come back after if you need to lighten it just that little bit. But don't forget, when you're starting off with this, you're going to find it a little bit difficult to get smooth curves. And the more you do, the easier it gets. Now, I'm just after taking those few minutes there just to, I suppose, clean up the curves a little bit, rub out any little bit of imperfection that was there. Now, we don't really worry too much about it. We get them as good as you can and we work on from there. What I'd like to move on to next now is just, it's very rare in graphics that they'll give us a question that's so easy as one of those where all the information is presented. They have to put you thinking. There's always some problem solving involved in this subject. So here's a little bit. What we're given here is a major circle, and I'm going to pick a point, and I'm going to pick a point right here. That is point P, and I'm going to say that point P is a point on the ellipse. We do not have the minor. We have the major, and we have a point that lies on the curve. Now that could be anywhere on the curve, anywhere at all. It will not, unless I'm very unlucky with where I drop my point P, it would not end up being exactly here or exactly here. It might be there, for example. So it might just be a random point P somewhere on the curve. That's our next little bit of problem solving. Take a few minutes yourself, pause the video, have a look, try and solve it before you see how I do it. To solve this, we're just going to be referring directly to what's beside it. We better write down what the question is first of all. Major axis equals 120, and there's a point P on the ellipse. Point P on the ellipse, and we would need to know as well that it's a horizontal, and this one is a horizontal again. And down here I'm going to give minor axis given. Minor axis is given. We'll drop in a point P on the curve, and this one's going to be a vertical ellipse, and I'm going to put the point P somewhere here. When you're setting up these questions, would you just make sure that you kind of keep the, don't go wildly off of where I am, roughly in proportion to whatever I put P here, and roughly in proportion to where I put P here. Don't drop it all the way out there or all the way in close to the axis there. Just, keep the proportions somewhat similar to what I have. So I'll highlight those questions again. So question 2 here is the major axis is given as 120 and a point P on the ellipse is given. And question 5 here, the minor axis is given and a point P which is on the curve is given. So let's get going on this one here. What I'm going to do to solve this, I'm going to go straight back to this one here, and I'm going to grab a pink color here just to make it stand out. From any point on this curve I can reverse my method. So my method was, let's just say off this 30-degree line, I go down from the major and across from the minor to get a point. From any point on the curve I can reverse my method. And what do I mean by that? I mean that I can go from the point up to the major, then I can link it in to the center of the two circles. So from there into the center of the two circles right there. And finally, just like I did with all of these, I can go across to hit the minor. So from the point on the curve across to hit the minor. So if I can use that little principle up to the major, in to center, and then across to hit the minor. If I can use that principle right there, then I can solve the next question. Let's just do that. So we won't make the big mistake here. I think the huge mistake that I'm used to seeing here is that someone just does this and they say, oh, I'm going to open the compass and drop it on P. You are not told that. You're not told that P is on the minor. You're told P is on the actual ellipse. So let's go ahead and do it using the exact same method. Up to hit the major, from the major in to hit the center, and then from P across to hit that angled line gives you a point on the minor circle. So from P across to hit that angled line right there gives me a point on the minor circle. Right there. There's my minor. There's the minor going through the intersection of the slope line that goes in and the horizontal line, or the line parallel to the major, that goes across. The interesting thing here is everyone watching the video will have P in a slightly different location, and everyone watching the video might have a slightly different minor than I have. So the rule will still stand. A couple of little arrows here might guide us, and just when we use this sheet and we come back to us time and time again as a little refresher on the topic, we'll remember that that's how we solved it, and we'll know that that's what we were given. At this stage I'm going to go ahead and drop in some extra points. I can use my 30 and 60 like this, or I can actually use any line at any angle. We're just in such a habit of using the 30-60 simply because it's fast and accurate, and it gives us a sufficient number of points to solve the question. Once I've it broken up there, I'm going to go ahead, and I should have done this just before, use my what I started off with here, identify the 4 points. So it's on the major along here horizontally, and it's on the minor up here, and it just makes sense because it's going to go there, it's going to catch this point P and go back down. We'll take it from there with the same methods as before. So down from the major, down from the major, across from the minor, across from the minor, and we can start joining all of our points together. Now I'm gonna, once again, I'll pause the video. I don't want anyone watching all of this. It's a bit pointless in seeing all of this again, but we're going to be going up and across, up parallel to the minor, parallel to the major. So I'll pause the video. Once we're back, I'll have this curve drawn through point P using this selection of points that I had just started forming right there. Now there's that ellipse just constructed and penciled in. That is the process and the way we need to use. It is the exact same. It's all based on our basic construction here, and it's used to solve a problem over here. Let's go ahead for this one. So the minor axis and a point in the curve is given this time here, and so we had the major and a point in the curve, we have a minor and a point in the curve. So this time, what do we do? We're going to just look back at our basic one again. I'm going to just use, I might use green this time as my color of choice. And I'm going to take a point on the curve here. So I'll just take this guy right here. And I'm going to construct that point, or reconstruct it or deconstruct it. We'll just do it backwards. So I'm going to look at what I did before. So for this point right here, I came vertical or parallel to the major. I came out through that point and across. So let's just see how that works. I can go across the major here. I can go into the center here. And I can go from the point down to hit the minor. So it's that little set of three in green right there. Should be enough to help me to solve this. They're both vertical ellipses. We have a minor and a point in the curve. So let's have a look. From the point in the curve, we want to go down onto the minor first of all. So it's down to the minor first of all. From the point on curve, down to the minor. Now, we would like to go across to hit the major, but we don't have a major. This slope line joins the center to the major through the point on the minor. So center to the major through the point on the minor. So we'll go ahead and draw that one. So from the center through the point on the minor, out here to find the major someplace, and the final line is from the point on the curve across to strike our slope line. Now, once we have that drawn, we have a major. Once we have a major, we have all we need to finish this drawing. So, same as before. We'll break it 30-60. And we'll use our method here. And before I do, I should identify my 4 points. There's the major standing up, and there's the minor in here. So it's being compressed in from the sides. It's being compressed in from the major. So I'm going to go in from the major, in from the major. It's being brought up from the minor, up from the minor. And you just already start to see how the curve here is going to form. Once again, I'm going to pause this video for a few moments. I'm going to finish off constructing and heavying in the curve, and then we'll take it on to question 5 and 6. Now, while the video was paused there for me, I finished off constructing this ellipse here. I just joined all the dots and got it outlined. But I also made one little change. I had a small mistake there. I forgot on the top at the very beginning of the video. This one here should be a minor, not a major. So I just rubbed out the large circle, which was a radius 60, and I think I brought it down to about 37 or 38 mil. It's not really relevant. Just if you wouldn't mind, rub out your large circle and just make it a small one. And just like here, then I just flipped them by mistake. So if you rub out that small size 36 or 7 mil circle you have, and just make it about a size 60, radius 60 there, just to have the I want all of the same vertical beside each other, and I want the horizontal beside each other. If I go ahead and just give the detail there for drawing number 3, the minor axis is given. And a point P on the ellipse. And I'm going to just, I'm going to drop that around here. Point P there on the ellipse in the middle of that little crosshairs. And once again, just a little indication, it is going to be a horizontal ellipse, just like that. And to outline what question 6 is, major axis given. Okay. Point P on the curve is given. And once again, like all the ones in the bottom row, it's a vertical ellipse. So there. Minor axis is given and point P in the ellipse. Now I haven't forgotten, but let's just drop the point P's in there as well. And there's the major axis is given and a point P on the ellipse for a vertical. Now I have point P dropped in here, and I'm going to just drop point P here. Okay. Starting off here with number 3. As I did all along, I'm doing the horizontal first, vertical second, horizontal first, vertical second, and the same thing this time. So number 3, the minor axis is given and a point P which lies on the ellipse is given. What I'm going to do, just a slightly different approach, I'm going to just recognize first of all, it's a horizontal ellipse, so it's going to be touching those 2 points. It's going to come out and hit P, and it's going to go down and hit the major circle. So how do I do it? I'm going to just have a look back. I'm not going to do anything really here with colour this time. I'm going to just have a look back to some of the questions I already did. If we come from a point on the curve, across to hit the curve, first of all. So take it from any point on the curve, across to hit the minor. We can then go from the out through that point from the centre and up to hit the major. So from that point, joined into centre, up at an angle, and to intersect it with a vertical line right there will give me the major. So your understanding of the basics of the horizontal and vertical will allow you to solve all 6 or all 4 extra questions that are presented on this sheet. And there we go. That's the major. So by going from point P across to hit the minor, from the center up through that point, and from point P up to intersect on the major, we'll solve this part of the question. And just, I'm sure you're starting to get the idea now. I'm going to pause the video again there in just a few seconds, and I'm going to go ahead and finish constructing this one. So we'll just, again, like just about all the time, we go ahead, break it into our 12, identify the 2 remaining points that are on the ellipse. I already identified my minor, now I'm identifying my major, and identify what movement has to happen from the major down and then relate it to the point in the minor. So from the major down and up and down, and then it's going to be across from the minor, across from the minor, and I start to form my ellipse. Once again, I'll pause it now. I'll just get this half finished. We'll move on to the last one on the page, but I have some extras to add in here and there as well. And there we have the finished ellipse for question number 3, where we were given the minor axis and given a point P on the ellipse. Final one for this page before I put in a couple of my extras in there is going to be the major axis is given and a point P on the curve. So I'm going to just look back at what I've already done and see how I can link in that information to solve this question. So looking at vertically orientated ellipses from any point on the curve, this time what have I? I have a point in major. I can come across to the major, into center and down. So if I just go ahead and do that, I'm going to come and just like I did actually the last time, I might just identify the points I can. Those two are on the ellipse. So what did I say? I said I go across to the major, into the center and down. So from point P, across to the major, from the major, into the center, and from point P, drop it down. And that gives me my minor axis. Once we're here, let's construct and finish this ellipse. Let's identify the next 2 points that are on the curve, and let's apply our method. So where are we going this time? We're going in from the major and up from the minor. In from the major, in from the major, up from the minor, and again start to form. Now, one more pause in the video and I'll get this construction finished. Oh, there's that last ellipse drawn in. What I'd just like to bring everyone's attention to is this. I just put the points, just for continuity really, as we went through the questions, I put the points all up here in the top right hand quarter of each of the questions. But would you be able to work with them if the point given had been down the bottom left, or down the bottom right, or up in the top left? Would it really make a difference? Would you know what to do? Well, the main thing is this, okay? This is the real, I think, the biggest key point of this whole thing is, I'll just put it in over here maybe. Once you get a question based on the ellipse, you need to start off with one of 2 sketches, and it's either going to be this one here, which shows angle down and across, and that's going to be for your horizontal ellipse, or it's going to be this one here, and it's going to show the angle in and up, and that's for your vertical ellipse. You will need to start off with one of those basic little sketches. Now you might have a bit more space of course on your page so that you can at least see all the detail. Kind of hard to see it there in mine, but a basic sketch like that, okay, that is always going to be your starting sketch. when you start doing any problem solving with the ellipse. Identify, is it a horizontal one or is it a vertical, and sketch in the method needed for your horizontal or the method needed to draw vertical, and at least you'll know then that you can refer back to that time and time again to solve the question, no matter which quarter, whether it's the bottom left, top right, or bottom right. No matter which quarter you're given a point in, you need to be able to refer back. So if it was this question right here and the ellipse is a vertical, well, that's my little sketch on my page. The point is down low, and all I'm going to do is I'm going to just drop in two circles. I'm going to say, right, where would I find my point for a vertical? I would find it by going in and down. That's it. If I have that, I can work backwards. So that's a really important point. The next important point, I think, is the terminology here, and actually getting to know the words and getting comfortable and familiar with the words associated with the topic. And I'm going to just set out a little guideline here at the bottom of my page, maybe about 5 mil apart or so, and just write down a few of the key terms we've come across. Starting off, ellipse. E-L-L-I-P-S-E. We have major axis. We have minor axis. What we also have, and I didn't really mention, is the axis is the line joining one end of the major to the other through the center of the object. So the major axis is the larger circle, the line that goes through, and the minor axis is the line along the smaller circle going through. What the actual circle itself is called is the major auxiliary, A-U-X-I-L-I-A-R-Y circle. So that is the major auxiliary circle, and then of course we also have the minor auxiliary circle. I'm running out of guidelines there, so I'll extend them on a little bit because there's two more things I'd like to drop in here as well. So, major auxiliary, minor auxiliary. Now, whatever way you feel like, if you want to add more notes above these points, please do so. I've three more things I'd like to add in here. Number one here is focal points. F-O-C-A-L points. The next one is tangent. And the last one for this sheet is normal. N-O-R-M-A-L. Now, focal points, tangents and normals are a huge part of this topic, and we're not going to worry too much about why they exist or where they come from or anything. What I'm going to tell you is that, as you might have seen in class, every ellipse has two focal points, and the focal points will be a constant fixed position on a particular ellipse, and for a different ellipse then they will change position. But the rule of finding focal points, okay, so if I just put this rule, I'm running out of space on this page, but it's great. We'll have loads and loads and loads dropped in here. If I just put my rule here, maybe over in this little bit of space, so anything in red might be just an extra little principle or an extra little bit of learning here for us. So F-O-C-A-L points, and the rule is you take half the major from the minor, and we call them F1 and F2. So the focal points is half the major from the minor. Now you might hear or read in books like they'll say half the major from the top of the minor is the usual way you'll hear it, but I don't usually say that, and there's a reason for it. Half the major from the minor. So the point on the minor that's on the curve is what I'd like to call it. I didn't have space to read it. To write it. You take half of your major circle and you swing it from the point of the minor that's on the curve. Now, that's also a point of the minor that's on the curve. Would it have worked? It would work absolutely perfect because they cross in the exact same position along the axis. So that right there is F1, and that right there is F2. Focal point number 1 and focal point number 2. Now, those focal points have a number of uses really in real life, and there's just a number of rules and principles also associated with them. You'll see if you look online, and if you go to YouTube and have a quick search and just say elliptical pool table, you'll see that if you had a pool table in the exact shape of this ellipse here, or any ellipse, and you put a ball on this spot and you hit that ball and hit the cushion anywhere, it'll rebound back perfectly over the second focal. So any point at all, as long as you hit a ball from the first focal, hits the cushion and rebounds to hit the second focal. It's a shape that's used also in gardening, and it's used in architecture and design. It's also used for certain medical applications where a laser might be emitted from one focal and it hits any side of the unit or the machine or the tank, and it destroys whatever is put at the second focal. So look, just 2 points that have certain relations with the curve. There's the focal. So to find your focal points, once again, we'll find the focal points down here. I'm going to take half of the major and I'm going to swing it from the point on the minor that's on the ellipse. So don't do this. That point is not on the ellipse, this one right here. So the focal cannot be outside. The focal points have to be contained within the curve itself. So half the major from the point on the minor that lies on the curve. So there. And the focal points are also always on the major axis. So the major this time is the big one that stands up here through, and I'm going to call that F1, F2. I could have called that one F1 and that one F2. It really doesn't matter. You can label them in whatever order you like. There's my focal points dropped in. Now, what good are they and what use are they is the next question. I would like to find a tangent, and a tangent is an exact line that is touching up against the curve at one point only. It's not a chord that goes through, touching right through the curve. It's only touching externally at one exact point only. Now, I think I have the perfect question set up right here. If I call that point, I'll call that point M right there. I want to find a tangent to the ellipse at point M, and it's not going to look like that because that's going through the curve. It's going to look something like this. Okay, let's get going on that one. The first thing we need to do to find the tangent is we need to find the focal point. So take half the major and swing it from a point on the minor that's on the curve. That's not on the curve, that is. So we get that point and that point. Again, I could have swung from below. I would still end up at the exact same points. So to find the tangent, we first find our F1 and our F2 focal points. For our tangent, and I'm going to put this just in here again in red, just all of our little extras that I'm adding in here and there are going to go in here in red. For our tangent, T-A-N-G-E-N-T. For a tangent, first you find the focals. Second, join focals to the point. So join the focal points to the point. So take the focal point, join down to M, and just keep it going, extend it on out a little bit. Join the focal point to M and extend it on out. That's the second step. And the third step then is to bisect. Now, what do we bisect is the big question. I've done step one. Step one is to find the two focal points. Step two is to join the focal points through point M. Join the focal through point M. Now, what are we looking for? I'm looking for to bisect either this angle inside here or the opposite one outside, in which case I'll get a line like that. That's no good to me. But if I bisect this angle here, the angle between this line and this line, so if I bisect that angle, I get this as my bisector, and that bisector is a perfect tangent. So let's go ahead and bisect. So put your compass down at point M, open it up any size you want, strike onto one red line, strike onto the other. Where those strikes are on the red line, now this actually happens to cross the major. I'm gonna just make that a little bit bigger. I don't want to touch on the major now. I don't want any real coincidence happening here. So from this point, move up. You can change the setting of your compass, or you can leave it. I'm going to leave it. And strike an arc. And where was I again? Out here. From that point. Now, what do I get after all of that? After all of that, I get this point right here. And that point joined into M and extended on through gives me a perfect tangent. So perfect tangent to the curve up there using our 3 steps. Find the focal points, join the focals to the point on the curve, to the point, and I'm going to call that of contact. That is the point that the tangent comes into contact with the ellipse. And the third step is to bisect the angle. The final word I had dropped down here, so I had focal points, tangent, and normal. And normal is a line that's at 90 degrees to a tangent. I'd like to go and find it maybe as a completely separate, maybe down in this one right here or something. I want to do this as a separate little diagram so that we can see it clearly. Once again, I want to put some notes in here. So anything in red is like my extra work, extra notes that are going in. So normal. This is really easy because it's the same, much the same process. First, find focals. Second step is also the same. Join focals. So I'm going to call it this time POC, the point of contact. I've already actually set a point right there. Since earlier on when we were chatting through the other part of the questions, I'm going to use that point. I'm going to call that point point N right there. First off, let's find the focal points. So take half the major from a point on the minor on the curve. So either this one or this one, whichever you like. There, that point is on the minor and on the curve. So there we go. We get our focals, our F1, F2. Step 2. Join the focals to the point of contact. Join the focal to the point of contact. Join the other focal to the point of contact. And step 3. Third. It's bisect. But it can't be the same because it's a completely different line. That's the tangent. That's the normal. So instead of bisecting this outside angle, I'm going to bisect this inside angle. So that's the only difference. So the steps are written the same way. Open your compass to whatever you like. Strike both lines. I'm going to open bigger this time. And strike again. There we have it. We have a point here. Joined up to point N. Is the normal. N-O-R-M-A. And if I wanted to find the tangent, I just bisect this external angle or this external angle. That really is all there is to do on this worksheet here. There's quite a lot in it. We have different scenarios of questions given there in yellow, and then we have our start off sketches that you should always use for these questions here in red. We have our method of finding focal points, we have our method of finding a tangent, and we have our method of finding normals. The only extra little note I'd like to add in here is this distance from the minor right down there to the focal is equal to half the major. Same down here. The distance, I might actually add it on a new diagram not to overload this one. If I take half the major from a point on the curve in the minor, I can label those as F1, F2, and I can take note that that distance there from the minor to the focal is equal to half the major. And half the major is this distance out here. Now, as I said, there's quite a lot going on in that sheet. It's a basic enough sheet. There's it's all the basics of the question. It's just different scenarios where you might be given major and point, minor and point for vertical and horizontal ellipse. And as I said, focal points, tangents and normals all dropped in there. This is probably the smallest but the most important little note on the page. When you start one of these questions, you need to ask yourself first, is it a horizontal or is it a vertical ellipse? Once you've identified which one it is, drop in the sketch that shows the method for finding any one point. That's all you need, just one point. Sketch that on the side of your exam or your homework sheet or whatever it is. Sketch this beside the question before you start the question. And when you come to the hard part where you're trying to figure out, right, I have a minor and a point, well, this little diagram here gives you all the information you need to solve it. Just ensures that there's no silly mistakes when you're getting into some of these questions. That's it for part 1 of this video. In part 2, I'm going to take it on to a little bit more difficulty and just different forms of question. This is the basics. That all of the important terminology is here across the bottom of the page. Ellipse, major axis, minor axis, major auxiliary circle, minor auxiliary circle, focal points, tangents and normals. So all of that important terminology will be going through to the next page with us. This sheet should be kept on your wall. It's a sheet that you can come back to at any stage if you're stuck with the basics of the ellipse. Thanks very much for watching. Please tune in for sheet 2 for the second part of this video, where I'll take you on to some much harder exercises.